No, it's not a reason. No.
Didn't he die?
I mean, everyone dies.
Then he did not use it well enough.
Wow, okay. Hey, my name is Manny Almo, Mr. Gossel, Senior Gossel, Profe Gossel, if you will. Okay.
Profe? I thought that means Profe?
Hey, I'll be
No.
Profe means teacher.
It means actually
Okay.
Oh.
I'm going to go ahead and start. Deductive reasoning, the process of reasoning logically and drawing a conclusion from given facts and statements.
Dang.
I know.
I
Okay.
want to laugh so much. I don't know why.
Okay, cool. The process of reasoning logically and drawing a conclusion from given facts and statements. No, what am I going to ask you to do? What am I going to ask you to do?
Put it down further.
You're very smart. Thank you. Appreciate you doing that. Okay, the process of reasoning logically and drawing a conclusion from given facts and statements. We're saying based on what we have, what can we deduce or come up with? What conclusion can we have from what we're given? Okay. So now one of the types is called the law of detachment. We're going to learn two different laws today. One of them is the law of detachment. Okay. Given a conditional statement, that's like our P then Q. Okay, that's like our P and Q. If P then Q. If the hypothesis, what letter was hypothesis?
H.
P. If the hypothesis is true, then the conditional, which was Q, is also true. Okay? So we're saying that given a conditional statement, if the hypothesis is true, then the conditional is true. If the first part's true, the second part is going to be true in our conditional statements. Okay? If it's a true conditional statement, that's how it'll be. Okay?
Okay, can you read that one more time?
We'll watch a video about this.
Okay, cool.
So we have a symbolic map, okay? So this map, we're going to draw it out with symbols, okay? It might be a little confusing at first, but I think it'll make more sense afterwards too, okay? So we're starting off, and notice how I'm not using the whole box right now. P, then Q. That's our conditional statement. We're given our conditional statement. Okay? Given a conditional statement. If P, then Q. And we're also going to be given that the hypothesis is true. So we're given the conditional statement, and we're also given that the hypothesis P is true.
Do you have to remember this?
You don't have to remember the map. It's just like a helpful way for us to see it visually. Okay? We'll say then, and we'll draw these three little dots here. Those three little dots is just a symbol meaning therefore. Those three little dots mean therefore, okay? If you want to, you can write off to the side.
What does the line
that
mean?
means therefore.
What?
It's just telling us this is what we're given. Everything above the line is what we're given. Below the line, if we're given a conditional statement and we're given that the hypothesis is true, therefore, Q is true.
Who made this up? Yeah, why can't we
Okay.
just write there?
It's just shorthand and right there for them, but you're not gonna want to when you got a whole bunch of sentences to write.
Okay. So if we look at the word detachment, that word detach is key for us. Detach means what?
Take away.
Okay.
Break
Taken
apart.
away, broken apart,
Separate.
separated, okay? So here, we took our P and our Q, and what did we do? We broke them apart. We detached the P from the Q. Okay, for our law of detachment, we detached the P and the Q, and we'll see this a little bit in the video here right now. So please watch this video and follow along.
Yay. Wait, is this like the singing video?
No.
Today we're going to dive more deeply into deductive reasoning, which is also called logical reasoning. We're going to look at some given conditional statements to make facts or conclusion. we're specifically going to look at the law of detachment and the law of syllogism. We're going to start with the law of detachment. It says that we need to identify the hypothesis. If another statement has the same hypothesis, then you can make a conclusion. Let's look at a given statement because then this will make a lot more sense. Let's say that we're given the statement, if there is lightning, then it is not safe to be outside.
Okay, that's just a conditional statement, right? If there is lightning, then it is not safe to be outside. What's our hypothesis?
There is lightning.
There is lightning. What's the conclusion?
It's not safe.
It is not safe to be outside. Everything following the then. Okay?
Well, then we're told that Preston is outside playing baseball, and then he looks up and he sees some thunder and lightning. Well, we could say Preston sees lightning from the baseball field. And see, it's not an exact match to our original conditional statement, but it's the same idea. The hypotheses are the same. If there's
So is it still saying that the hypothesis is true here? If there is lightning? If Preston sees lightning, is that hypothesis true?
Yeah.
Yeah, there's lightning, okay? So even though it's not word for word, it's still saying that the hypothesis is true, okay?
But it doesn't
So
say that it's not safe to be outside.
that's true. We're not talking about that. We're talking about the conclusion now in a second. According to our law of detachment, if there is lightning,
Preston sees lightning. Well, then we can make the same conclusion. It is not safe for Preston to be outside.
is that true? If there's lightning, is it safe to be outside?
I mean, there's literally a 0 point.
Okay, well, a person in my town when I was growing up got struck by lightning and died, so
Oh, that's
probably not
aggressively sad.
safe. Okay, so is it true that if there's lightning, it's not safe to be outside? Yeah. So if Preston saw lightning, then we can draw the conclusion to be true. So we can say the conclusion would be true then because the hypothesis was true. Okay? Now we'll talk about what happens if you reverse
Now, let's take a look at the same conditional statement. If there is lightning, then it is not safe to be outside. But this time, we're going to do a restatement of the conclusion rather than the hypothesis. It's not safe for Preston to be outside.
Okay? So now we're saying we're given the same conditional. Instead of saying that there's lightning, we're now saying the conclusion is true. It's not safe for him to be outside. What do we think we know from this?
I mean, not safe to be outside.
Okay, we know it's not safe to be outside. We're given that. Do we know if there's lightning?
No.
Could there be lightning?
Yes.
Sure, but do we know there is?
No.
No, is that the only reason it'd be unsafe for him to be outside?
Nope.
No, there could be.
Tornado, tsunami.
Okay, tornadoes, not other natural disasters. Okay, and we're going to talk about other options here. Let's look at this.
Well, you know what? There could be a lot of reasons why it's not safe for Preston to be outside. Well, what if there are lions roaming around? Definitely not safe to be outside. Or what if there's a big, huge windstorm? Whoa, definitely not safe. Well, what if there are little green alien men running around all over the
I'm
place?
done. Turn it
Def-
off.
Isn't that what it is? That not the sound an alien would make?
No.
It totally is. Okay,
Definitely, definitely not safe to be outside. Well, again, there could be a million reasons why it's not safe to be outside. We just cannot make a conclusion when there's a restatement of the conclusion. So, to summarize, the law of detachment says that we need to identify the hypothesis. If another statement has the same hypothesis, we can make a conclusion. Putting it into our symbolic notation, if P, then Q is true, and P is true, and again, P is just a restatement of the hypothesis. It doesn't have to be word for word verbatim. Well, then Q is true.
Okay. So hopefully that's a little more of an explanation for us as we go through it, okay? And she really followed that same symbolic map, just instead of those 3 dots to therefore, which you guys apparently don't like. You already had this, Grace.
No,
Gracie.
I know. I'm ready. What?
I misspoke.
Yeah, you did misspoke.
Sorry, I'm used to telling you to calm down. My bad.
Oh, very funny. You're very funny.
That's going on. I know.
You're very
So we're gonna use the law of detachment to see if we can give a valid conclusion, and if we can't, we're going to write no valid conclusion. Yes. Still?
Yeah.
What did you do the first time?
I did it.
Oh, you're writing on the link?
Yeah.
They could have sent it to you.
Not that good.
Okay. That's what you.
Why would you?
Okay.
I can never.
So,
do those.
If Mark saves $30, then he can buy a new video game. This is one of the lines we're given. Mark saves $30. Is that the hypothesis or conclusion?
Hypothesis.
That's our P. Then he can buy a new video game. He can buy a new video game is the conclusion, our Q, okay? That's one line we're given. We're given the conditional statement. We're given if P, then Q. That's what we're given. What else are we given?
Mark saves.
Mark saves $30. Is that telling us the hypothesis is true?
Yeah.
So, we're told if P then Q, we're told the hypothesis is true. According to our law of attachment, what can we say is now true?
The conclusion is true.
That the conclusion is true, that Mark can buy a new video game. Our conclusion is that he can buy a new video game. The first part is true, so the second part is automatically true, according to the law of attachment, where we detach the hypothesis from the conclusion. Okay, we separated the hypothesis from the conclusion. Okay, let's look at number 2. If a quadrilateral is a rhombus, then it is also a parallelogram. Let's look at this first line of information we're given. A quadrilateral is a rhombus. What is that? The hypothesis, our P. Then it is also a parallelogram. It is also a parallelogram is our conclusion, our Q. Okay? So we're given our conditional statement, if P then Q. I think it's helpful for us to draw these, to label things. Okay? If we label things, I think it's helpful for us to keep it straightforward, right, Kale? I'm glad you agree, okay? Quadrilateral ABCD is a rhombus. What's that telling us?
It's a rhombus.
Okay? Is that a repeat of the hypothesis or the conclusion or neither?
Neither.
Okay? Hypothesis, because we're saying if a quadrilateral is a rhombus, now we're saying this quadrilateral is a rhombus. That's like if there is lightning and Preston sees lightning. It's not word for word, but is it still saying it's true? Yeah, so we still have P. Okay? So what conclusion can we draw? If we are
ABCD is also parallel.
yeah, we can say it's also a parallelogram. So I'm just gonna say it is also a parallelogram. If we wanted to, we could actually say quadrilateral ABCD is also a parallelogram. Our law of attachment tells us that we can, if we're given the first part is true, we can say the second part is automatically true. Okay? Questions on 1 and 2. Let's go down to number 3. Okay? If you are 18 years old, then you can register to vote. Okay? You are 18 years old is what part?
The
Hypothesis, our P. You can register to vote is what part? Conclusion. So we have our conditional statement. If P, then Q. Let's label that. Okay? Then, what are we told? Olivia is not 18 years old. Are we told P?
Yeah. Well, I mean, kind of.
Kind of. What are we told?
We're told that P is a lie.
P is a lie, so we're told not P. We added the word not. Okay? So, according to law of attachment, did it say anything about another scenario other than we're just given normal P? No. So can we draw a conclusion?
Not possible.
No. So we put no valid conclusion. No valid conclusion. It's not possible to draw a conclusion. So we say there's no valid conclusion we can draw. And you might say, Mr. Kossel, what does that mean she can't register to vote? Okay, well, let me tell you this. I'm 23 years old. Can I register to vote?
Yes.
But I'm not 18. So you say Mr. Kossel's not 18 years old, but I can still register to vote. So we can't draw a conclusion, okay? Because we don't know which side of 18 they're on. Oh. There's a what? What do you mean a thing?
You could be 23 years old or 18 years old.
I feel like.
Okay.
Boom.
So we'll assume they're a U.S. citizen for this part then, and not a felon. Yeah. Good point.
You can still be a U.S. citizen and be a felon.
Yes, we're gonna assume you're a U.S. citizen, number one. We're also gonna assume you're not a felon.
Oh, I was about to say. That doesn't.
I feel like this is just like not like you have to blind yourself to common sense.
No, because Mr. Carlson's not 18 years old. Mr.
I know.
Carlson can register to vote.
But like exactly.
Okay, but you can register.
But
to vote.
you're talking
I can't.
about how it doesn't talk about
But-
rights on it.
Are you 18 years old, Grace?
No,
Can you register to vote?
no.
So we can't draw a conclusion just by saying whether or not someone's 18 and they can vote.
So
Because neither of us are 18, one of us can register to vote, one of us can't. So this cannot tell us whether we can draw a conclusion. Yes. Right. Yes.
Huh?
We need to finish watching the video later.
so
Okay?
dumb.
I
I
know
don't
you're doing
understand. This is just
Sorry, Bill. Okay.
I
Number
started
4.
to feel that way. I'm Grace Vandenberg.
That's me. Okay. Let's look at number 4. Okay. If the sum of the measures of two angles is 90 degrees, then they are complementary. You know that's true. If you add two angles together and they get 90 degrees, it's complementary.
yeah.
The sum of two angles is 90 degrees. Is which part? P or Q? P. Our hypothesis. They are complementary. Is which part?
Q.
Q. And what are we told? Well, we're told measure of angle J is equal to 58 degrees, and measure of angle K is equal to 32 degrees.
Not
At first glance, we might say, well, that's not either the P or the Q. But if we look a little closer,
It is
it's which one?
the P
P. Why?
because 58 plus 32 equals 90.
Yeah, because these two do add up to 90. So, measure of angle J and measure of angle K do add up to 90 degrees. So what can we conclude then since the hypothesis is true?
That these are complementary.
That they're complementary angles. So we can say angle J and angle K are complementary.
I miss X's and Y's.
You never thought you'd say that sentence, did you?
No, I used to like hate algebra.
Yeah.
And now like it's so much easier to do this.
Really? This is so simple. I feel like this is just like
It's just a lot of work.
Yeah.
Like it's a lot of writing and it's
Yes,
really
okay.
boring.
If you plan to attend prom, then you must purchase a ticket. If you plan to attend prom, then you must purchase a ticket, okay? You plan to attend prom, that is A. You must purchase a ticket is,
Q.
okay? Sarah purchases a prom ticket. Sarah purchases a prom ticket.
Q.
That's Q.
Yeah.
Now, were we told that we can draw a conclusion or given the conclusion is true? No, we can't draw a conclusion. That's like saying it's not safe to go outside. We don't know there's lightning.
Oh, okay. So if the ending sentence thing is the same as P, then you have to draw a conclusion.
And the conclusion is Q, yeah.
Okay, and then after it's not, if it's just Q,
If it's anything other than normal P,
then there's no valid.
literally anything.
So
That
Q
is
means
so
good.
basic. More than so. What is?
Okay, so you might say, well, Mr. Carlson, if they buy a prom ticket, aren't they planning to attend prom? What if they buy a prom ticket for a friend? They might not be going to prom. Maybe they just were nice to their friend and bought them a ticket.
Maybe they just bought it and they didn't go.
Who knows? Maybe they just wanted to buy a ticket. Maybe they thought the ticket looked cool. Okay, cool.
Yeah.
Okay.
Maybe they got sick.
Okay, maybe they just want to see Mr. Carlson on prom. Who knows? Okay. So hey, continuing on.
Definitely not.
Why? You probably look good. Okay. So now we have the second law, the law of syllogism. The law of syllogism. Okay. This allows you to draw a conclusion from two conditional statements. Sorry. In which two conditional statements, in which the conclusion of the first is the same thing as the hypothesis of the second statement. We're saying the conclusion of the first statement and the hypothesis of the second statement are the same. If that happens, we can draw a conclusion.
Okay, wait, hold up. Allows. Okay. Re-say that one more time and explain it slowly.
So, if the conclusion of one statement, the ending of a statement, the Q,
Q.
is the same as the hypothesis of the next statement, a new statement,
Okay.
then we can draw a conclusion. Let me draw it in
so not
symbols.
from like the
Let
last.
me draw it in symbols. So we have our first conditional, if P, then Q.
Okay.
We're saying if the conclusion of the first, this Q, is the same as the hypothesis of the second, Q. What letter follows Q?
P. The
In
answer.
alphabet. in the alphabet?
W, I don't know. I'm guessing here.
QA.
Okay. So we have two different conditional statements.
Okay.
We're
Wait, why
saying.
would we do that if we? Okay.
Let me explain. Let's watch the video. If you still have a question, you can ask.
Do we have another video?
Okay. We have another part of the video.
This is.
Okay.
Just give it a chance.
Thank you.
I
Okay.
tried.
Continue trying, please.
Grace, what are you doing?
Okay. Nolan, stop. What's that? Oh, that's weird. Okay. Two conditional statements. Two conditional statements. Okay. We're saying the conclusion of one is the same as the hypothesis of the other. This Q is shared. If that's the case, if this is what we're given above the line, therefore we are able to conclude that we can go straight from P to R and skipping what was doubled.
So
We can, it's a new third
That's
statement. So
not
just like how on previous worksheets we've had multiple statements, we had like P, Q, R, S. It's just one of those. Okay, and we'll look at in the video. It explains that as well. Okay, so let's one watch this
so we're
video,
not
please.
flipping it?
No.
Wait, I didn't finish.
Okay, we'll get to it later.
Well, now let's look at the law of syllogism. And it says you can make a conclusion if the hypothesis and conclusion from two conditional statements are the same. Let's look at an example, make a lot more sense. Let's say we're given the statement, if everyone does their geometry homework, then they will pass geometry.
Okay, so that's a conditional statement, right? If everyone does their geometry homework, that would be P. Then they will pass geometry. They will pass geometry would be our Q. That's one conditional statement. She's going to write another one here.
If everyone passes geometry, then Mrs. Gray will have a party.
Notice that doesn't say Mr. Costa, okay? Hey, so this is the second conditional statement. If everyone passes geometry, then Mrs. Gray will have a party. What do we notice about this conclusion Q and this hypothesis?
It's completely like similar.
They're the same, okay? If they pass geometry, that's the same thing as everyone passing geometry,
Why do you get a different conclusion?
okay? Calm down. Let me just explain this. And not the video, okay? Please, thank you, okay? So we have the same conclusion as we do with this hypothesis, and then this is where the R comes from. It's something, a third statement that happens, okay?
Oh, so it has nothing to do with the hypothesis or the
Doesn't necessarily have to do anything to do with the other hypothesis or the original conclusion. It's a new conclusion. It's an R. It's a new statement.
Well, we can conclude then that if everyone does their geometry homework, well then, voila, Mrs. Gray is going to have a party with lots and lots of cake. Well, let's look again at our original statements. There is a match. We have a hypothesis that then we will pass geometry, and another match if everyone passes geometry. Well, we basically just crossed those out and combined our hypothesis that we started with and our conclusion that we ended with. We just crossed out the matches and combined what's left over.
So we went straight from the original hypothesis, if everyone does their geometry homework, to our last conclusion. Mrs. Gray will have a party, and Mrs. Gray will have a party. So we're able to skip over what's repeated. So this conclusion and this hypothesis were the same, so we skip over, and it does make sense actually. If we walk through this, let me walk through this one, okay? So if everyone passes their geometry homework, what will happen?
But that's not what she said. She said then they will pass geometry, but
Okay.
she says if everyone.
So Nolan, follow with me. If everyone passes their geometry homework, what's going to happen? Then they're going to pass geometry, right?
Yeah.
Now, so we know that they're going to pass geometry. Does that automatically make this part true then? That everyone passes geometry?
Yeah.
Okay? So it automatically makes this true. So
Wait, but
because
we don't
this
know
is...
because we don't know.
Let me finish. Thank you. Okay? So we already know that if everyone does their geometry homework, they're going to pass geometry. So we can already skip to down here. So if everybody passes geometry, do we know that Mrs. Gray will have a party?
Well, now we do.
Yeah, because we had the sentence twice, the statement twice. So we're able to kind of just cross those out and skip over it and smush the two together. So if everyone does their geometry homework, then she's going to throw a party. So it's just saying a sequence of events. If this happens, then this happens. If this happens and this happens. So that means this one leads to this one. Okay? If you guys turn 16 this year, the next year you'll turn 17. If you turn 17, the next year you'll turn 18. So if you turn 16, will you turn 18 in 2 years?
Yep.
Yeah. Okay. Disagree slightly, but okay.
What do you mean?
If everyone does their geometry homework, then Mrs. Gray will have a party. So to summarize, the law of syllogism says you can make a conclusion if a hypothesis and conclusion from two conditional statements are the same. And that's again where we saw that match. In putting it into our symbolic notation, if P then Q, if Q then R, well then we can conclude then if P then R. Again,
Okay? I'm not asking you guys to understand this perfectly right away. I'm not asking you guys to like it. I'm asking you guys to hold on and to let me try and explain it. Let's go through some examples and see if it makes more sense, okay? I'm not asking you guys to get it perfect. I'm not asking for it to make perfect sense. Okay, I'm really not. I just want you to hold on and be patient with me. Okay? So, continuing on with our notes, okay?
That's part of the problem why it doesn't make sense, because you're too busy doing other stuff. Doesn't make any difference.
Okay, couldn't agree more. Thank you, Ms. Haswell. So if we go down right below this, okay, we're going to see if we get this two conditional statements where those two match up. The first conclusion and the second hypothesis match up. If so, we can skip over them and combine them together. So, in this example, we're using the law of syllogism we just talked about to give a valid
Can you go back?
conclusion. Okay? And if we can't give a valid conclusion, we're going to write no valid conclusion, okay? If we can't give a valid conclusion, we're going to write no valid conclusion, okay? So the only time you can get a valid conclusion is when it's set up just like this. It has to be set up exactly like this. Yes, Marissa?
What if it's set up like that, but it's not right? Like, it
The
doesn't,
conclusion isn't right that they give?
like, yeah, it doesn't make any sense. Like, so, if I say, like,
Let's see if we have one of those examples and it pops up, okay?
okay, because
That might be
I
helpful.
already did them ahead of time.
So, we're given these two conditional statements. We're going to break them apart just like we did before. If it is Saturday, then Jake has a baseball tournament. Okay, it is Saturday. What is that letter?
That is P.
It's going to be our P, our first hypothesis. Then, Jake has a baseball tournament. Jake has a baseball tournament would be what? Q, our conclusion. So we go if P, then Q. And once again, I think it's helpful to label it. I think it's really helpful for us to label it. So I'm going to ask that everyone does that right now. Okay? So Kale, please go ahead and do that. Thank you. Okay. Then if we look at our second conditional statement, if Jake has a baseball tournament, have we seen Jake has a baseball tournament before?
Yeah.
And what did we call it?
Q.
So we're going to call it Q again. We're not going to change the name on us. We're going to call it Q again. Then he will need to pack his lunch. Have we seen he will need to pack his lunch yet?
No.
No.
It's R.
So that's R. That's a new statement. Okay? So this one, the second one goes if Q, then R. So did these line up where it goes P, then Q, then R? So the conclusion of the first is the same as the hypothesis of the second. Okay? It ends with Q, it starts with Q. So what we're able to do is go straight from P to R. We're able to skip over Q and go straight from P to R according to the law of syllogism. So we can say, if it is Saturday, our P, if it is Saturday, then he will need to pack his lunch. Do we know what he we're talking about though?
No.
So it might be helpful to say Jake, okay? If you want to say he, I will kind of go off for it, okay? Then Jake will need to pack his lunch. Okay. So, the first conditional statement is saying every single Saturday, Jake's gonna have a baseball tournament. Okay, that might be true for you, but it's true for Jake in this scenario, whoever Jake is. Okay. Now, if Jake has a baseball tournament, he's gonna need to pack his lunch for that tournament. So that means every single time it's a Saturday, he's gonna need his lunch because he has a baseball tournament. But we just don't even have to include that part that he has a baseball tournament, okay? We do this a lot of times in our life without even realizing it. We use this kind of reasoning without even realizing it, okay? On number 7, we're gonna do the same thing with our two conditional statements. If a number is divisible by 12, then it is divisible by 6. Following, if a number is divisible by 12, what would that be?
P.
P. Okay. Following the then, it is divisible by 6 would be our Q. Okay. Second conditional statement, we're going to do our same thing here. If a number is divisible by 6, then it is divisible by 3. A number is divisible by 6. Have we seen that before? Yeah. Now, we might say, Mr. Collisle, this is a little bit different, okay? Because Q was it is divisible by 6. This is saying a number is. So, we changed it to a number. Well, what was it representing anyway, though? A number. So, it's the same thing. Okay. Then, it is divisible by 3. Have we seen that one before? No. So, we're going to call it R, the next letter. So, we went on the first one, if P, then Q. On the second one, we went if Q, then R. So do we have those double Q's like right next to each other there? Or diagonal from each other, excuse me? Yeah. So we're able to go straight from P to R. And can somebody raise your hand and tell me what I would write here then as my if P, then R? Okay, go Marissa.
If the number is divisible by 12, then it is divisible by 3.
Exactly right. If a number is divisible by 12,
But is that like right?
that is right. Then
Oh, you're right.
it is divisible by 3. The other way around.
I
would
don't
not
know
be
why that didn't sound right.
true. No, you're good. The other way around would be true, but this way it is. And according to the law of syllogism, we're able to make this conclusion. We're going to go ahead and skip number 8 here. We're going to skip number 8 here. Okay. We're going to go on to number 9. Okay. Number 9. If it is sunny this weekend, then you will go boating. Okay. So what's our hypothesis going to be here, Wyatt? Yeah, it is sunny this weekend. Okay. So what does that make our conclusion, Wyatt? Yeah, you will go boating. Everything after the end. So this goes P, if P, then Q. Okay. Now in our second conditional statement, Nolan, what's our hypothesis? What follows if in our second conditional statement? What? No, what follows if?
Oh, your hypothesis.
Yeah. It is sunny this weekend, okay? Have we had that before? What do we call it? And what are we going to call it this time? We're going to call it, are we going to say the same thing or different? Did it change? Same thing, it's P. Then you will wear shorts. You will wear shorts. What do we call that? Okay, we normally call it Q, but we've already used Q, so we'll use R. Very good catch. So this one goes, if P, then R. Does this follow the pattern we want? No, those diagonals do not match up. Okay? So if we have anything where these diagonals do not match up, can we draw a conclusion? No, we can't. Not necessarily, right? We can't draw a conclusion through this law. If we happen to know a lot more facts about what's going on, maybe we could know, but we don't. So just from this information, we can't say anything. Because it doesn't follow our pattern. These laws, it's all about the pattern. It's all about the pattern that's happening there. Okay? It's all about recognizing the pattern that's happening there. Okay? Let's try number 10 here. If you shop at Target, then you will use your Target red card. Okay, so what's our hypothesis here? Exactly right. We'll call it our P then, okay? Hey, and Mackenzie, what's our conclusion? Awesome. We'll call that Q, okay? So this first one goes if P, then Q, okay? And really all of our first ones will always go P, then Q on these, when we're drawing it out, okay? If we're given one as labeled, they might not have it labeled P, then Q, but when we label it, we'll always do P, then Q first. If you do not use your Target red card, is that kind of like one we saw earlier?
Oh, yeah, we want to have a negate.
But we have a negate. So this is not Q. Okay, all of a sudden this is not Q. Q is using your Target red card. This is not using your Target red card. Okay? You will not get 5% off. Have we had that one yet? No. No, this one called R. It's new. We went P to Q. Now we went not Q, not Q, to R. So do these two match up perfectly? Is it Q and normal Q? No, it's Q and not Q. So because they don't match up perfectly, we can make no valid conclusion. Once again, it's 100% about our pattern. 100% about our pattern. Okay? Okay. Questions on that one?
10 minutes.
Okay. We're going to skip over number 11 here. Okay. We're going to go to the next page. I hear those pages flipping. That's awesome. Okay. So this is just a little bit of summarizing what we've said so far, and then also applying something a little new to it, just kind of combining the two. Not necessarily like combining so they can use both at once, just figuring out which one's being used, if any. So we have our law of attachment, if P then Q. Then we have P is true, therefore we know Q is true. That's once again, is detached. That word detached there is huge for us, okay? P is detached from Q. That's how we can remember that law, okay? Because these are the two laws we're going to be asked to remember, okay? If we remember that P is detached from Q and the law of detachment, that'll help us. Syllogism is our other one. If P then Q, Q then R, so those two Q's were the same, therefore we can skip it and go P to R. Okay? So if you remember which one's attachment, then we can say, oh, well then the other one has to be syllogism. Like if you can say, oh, well, this is my left, well the other side has to be the right. So we're gonna here, right below this for these examples, we're given two different things. And then we're gonna be given a conclusion. And we're gonna say, did this follow the law of syllogism? Did this follow the law of attachment? Or neither? And if neither, we write invalid. So let's look over this and we'll label just like we have been. The first thing we're given, if I drive over the speed limit, then I will get a ticket. That's a conditional statement, if, then. I drive over the speed limit is going to be our P. I will get a ticket will be our what? Q, okay? I drove over the speed limit.
P.
That's P. Okay? So which law would we be set up to use then? If we only have, if it's
Law of
detached.
attachment.
It's law of detachment. Now let's look at our conclusion. I got a ticket. What's that line up with? I will get a ticket. Q. So does this follow our law of detachment perfectly?
Yeah.
Yeah. So our answer is that we're using the law of detachment. Okay? We're already given the conclusion. We're not asked to make a conclusion. We're asked to say, does this follow one of the laws? If so, which? In this case, this follows law of attachment. We had a conclusion, then we had our P and our Q detached, where P was true. The Q is also true. Okay? Questions on number 1. Okay? We're going to do a couple more examples of these. Okay? On number 2, if Amanda goes to the restaurant, then she will order a hamburger. Okay? Amanda goes to the restaurant, that would be what?
P.
P. She will order a hamburger is
Q.
Q. Okay? Our second one, if she orders a hamburger, then she will get fries. She orders a hamburger. Have we seen that?
Yeah.
What is Q? She will get fries. Have we seen that?
Nope.
That's R, okay? So we go P to Q and Q to R. So we should already be thinking, oh, we might go law of attachment here. But let's make sure our conclusion lines up. Because what should our conclusion be? P to what letter?
Q to R.
It should be P to R, so let's check. Amanda goes to the restaurant. Is that P? Okay, good start. Then she will get fries. Is that R? So it did go P to R. So we did in fact use the law of syllogism. We did in fact use our law of syllogism there. Okay? Detachment is where they're detached. Okay, you have P and Q separate. Okay, in separate parts. Okay, here our syllogism, we have 3 different conditional statements. We had a conditional statement, P to Q, conditional statement, Q to R, conclusion conditional statement, P to R. Okay, let's look over example 3. If it snows, then I will wear my snow boots. It snows. That's R.
P.
Okay, I will wear my snow boots is Q. Second, so this one goes P to Q. The second given. If it snows, then I won't go to school that day. It snows. What is that?
P.
P. We've seen that before. Very good, Marissa. I won't go to school that day. Have we seen that one?
No.
It's R. So we go P to R. So we should already be seeing, can we draw anything from this?
No.
Let's double check though, just to make sure. If I don't go to school, okay, that goes R, Then I will wear my snow boots. Q. Is there anything that can tell us we ever go like R to Q like that, like a reverse order? No. So this is invalid. This is an invalid conclusion because you can't draw a valid conclusion. Yeah, we can't draw a valid conclusion with this. So it's an invalid conclusion. So it's either one of the two or it's invalid that we drew that conclusion. Okay, questions on that? Okay, we're going to skip past 4 and 5, as well as 6, 7, and 8. And we're going to go straight to number 9 here. Okay? And we're going to look over number 9. Number 9. This one's going to look really weird at first. This one's going to look really weird at first, okay? Use the law of syllogism to write 3 conditional statements that can be formed from the following true statements. We have these 5 statements, and we're told they're all true. These are 5 conditional statements, and we're told they're all true. We're going to go through, we're going to label them. We're going to label them starting at the top. A quadrilateral is a square. Have we seen that? It's P. It has 4 right angles. That would be Q. Okay? So this one goes P to Q. Second one. A quadrilateral is a rhombus. Is that a new thing that we've seen or an old one? P or Q? Or is it a new thing? It's R then. It's the next letter. Its opposite sides are parallel. Is that P, Q, or R, or is it a new one? So it follows, what follows R? S. So this one goes if R, then S. C. If a quadrilateral has 4 right angles, then it is a rectangle. A quadrilateral has 4 right angles. Have we seen that before?
Yeah.
It's Q. It is a rectangle. That is T. That's new to us. So this one goes if Q, then T.
Wait,
Okay.
so how do you get the S and the T?
Those are just the next letter because it's a new statement. Opposite sides are parallel. Have we seen that yet in either of these? Did this say opposite sides are parallel?
Oh, so you're like going
I'm continuing
in the
going.
alphabet?
Yep, I just went
Okay,
to the next letter.
okay, that makes sense.
Yep. If a quadrilateral is a rectangle, have we seen that one?
Yeah.
What did we call it? We call it T. Its opposite sides are congruent. Have we seen that one?
Nope.
We call it U, the next letter in the alphabet. We just picked the next letter. Not rocket science, we're just saying, what's the next letter? So we go if T, then U.
I have to count all the way down.
Okay? Yeah, 1, 2, 3, 4. Okay.
9.
If the opposite sides of a quadrilateral are parallel, what was that? That was our
S.
S. Then it is a parallelogram.
B.
That goes back to which one? Oh, does it? B. Okay. If S, then V. We're going to go over one of these answers, and then we'll be done for now, okay? So hold with me for one of these answers. So, we went through, we labeled all of this. Any questions on how we did the orange part there?
Yeah.
It's like what we did before, just on steroids. So now we're going to try and use our law of syllogism, which is one where we try and line up the conclusion with the hypothesis. If we look at any 2 of these, can we combine any 2 of these into a new thing?
Yeah.
Which one?
I don't know.
Okay. Here, this goes if P, then Q. Do any of these start with Q?
No. Yes, Q to T.
So can we go P to T? We can go if P, then T. For this, we go if P, then T. We can say if a quadrilateral is a square, then T, then it is a rectangle. Which is true. Okay? I won't make us write this one out, but we can also go from R down to V. Because we go R to S, S to V. We can also go from R down to V. Okay? And then there's a third one we could do as well. But just for time's sake, okay, I won't go to that one. Thank you guys for hanging with me. I appreciate you guys getting a lot more patient and calm after I asked you to. That means a lot to me. I really do appreciate that, guys. I hope it did make more sense by the end. If it doesn't, please come in before school tomorrow. Please come in after school today. Please come in, maybe not after school next week. Please come in before after school on Monday. Please go try and get something in study hall. Please try and get help. Please watch the video. You know, I want you guys to tell me you need help, okay? Yes.
Oh yeah. Also, I was assignments. do it twice, that means I get double credit, right?
Or if you get double zeros if you don't do them. Is that a risk you're